The ground beneath your feet is thinner than the skin of an apple, stretched over a globe the size of a beach ball. That's the entire crust of the Earth, the only layer you have ever touched. And you are about to fall through 12,742 kilometers of everything beneath it. This is layer 1 of 9, and by the time you reach the last one, distance itself stops meaning anything useful. Layer 1 is the crust, and it is a lie of scale. Under the oceans, it can be as thin as 5 kilometers. Under continents, it stretches to around 70. If Earth were shrunk down to the size of an egg, the crust would be thinner than the shell. You would fall through it in seconds, and the temperature would already be climbing past 200 degrees Celsius, before you even noticed you'd left daylight behind. No sky, no roots, no bedrock you recognize. Just heat, rising fast, and a floor that is about to stop being solid at all. But what's waiting past that floor is not rock in any way you'd recognize it, and that's where the real descent begins. You've been falling for what feels like minutes, and the walls around you have gone from gray stone to something closer to hot toffee. This is layer 2, the upper mantle, and it starts almost immediately below the crust and reaches down to roughly 410 kilometers. It is technically solid, but under enough time and pressure it flows like a liquid, moving at a few centimeters a year, slow enough that it built every mountain range and ocean trench on the surface without you ever feeling it move. Temperatures here climb past 900 degrees Celsius. Your body would not survive contact with this layer for even a fraction of a second, and the pressure alone would already be measured in tens of thousands of atmospheres. The mantle keeps this same slow-motion churn going for hundreds of kilometers, but somewhere inside layer 2, something changes, and it changes the rules for everything below it. That change has a name, the asthenosphere, and this is layer 3. Here the rock is closer to a thick plastic paste than anything resembling stone, softened just enough by the heat that entire tectonic plates ride on top of it like rafts on a slow, molten current. It is this layer, more than any other, that is responsible for continents drifting apart and colliding back together over hundreds of millions of years. Layer 3 sits roughly 100 to 200 kilometers down, and the pressure here would compress a human body before the heat ever finished the job. No bones, no structure, nothing left recognizable as a shape. If layer 3 is a slow, grinding current, the next boundary is where the mantle stops behaving like anything on the surface at all. What happens when rock stops being rock, not because it melts, but because it is squeezed into a completely different crystal structure? That's layer 4, the transition zone, sitting between about 410 and 660 kilometers deep. Under this specific combination of heat and crushing pressure, the same minerals found near the surface rearrange themselves atom by atom into denser forms, some of which scientists have only ever recreated for fractions of a second inside laboratory presses. Water is trapped here too, not as liquid, but locked inside these transformed crystal structures in quantities that some researchers estimate could rival the oceans above, an ocean hidden inside solid rock that has never seen the sky. That hidden ocean is strange enough on its own, but it's only a preview of how much bigger and stranger the mantle becomes as you keep falling. Layer 5 is the lower mantle, and it swallows more volume than almost anything else on this list. It stretches from 660 kilometers down to nearly 2,900 kilometers, making up more than half of Earth's entire volume by itself. Pressure here exceeds 1.3 million atmospheres. Temperatures climb past 2,200 degrees Celsius, hot enough to soften iron on the surface, yet the pressure is so extreme that the rock remains solid despite the heat. If you've made it this far into the planet's worst conditions, drop a like and subscribe. because the next boundary is where solid rock gives way to something that behaves like a molten metal ocean. And it changes everything about how this planet stays alive. That boundary has a name too, and it's one of the strangest surfaces in the solar system. You feel the floor beneath you turn to something closer to lava frozen mid-motion, jagged and uneven in a way nothing above it has been. This is the D double prime layer, layer 6, a thin, chaotic zone right at the base of the mantle, where scientists have detected enormous blob-like structures, some as wide as continents, sitting just above the boundary with the core. Nobody fully agrees on what these structures are made of, only that they are denser than the rock around them, and have likely sat in place for hundreds of millions of years. Layer 6 is barely 200 to 300 kilometers thick. It marks the last solid ground before the planet turns liquid. And on the other side of that liquid boundary, gravity itself starts pulling the compass out of your hand. Here is the unsettling part. Layer 7 is the outer core, and it is not rock at all. It is a spinning ocean of liquid iron and nickel, roughly 2,300 kilometers thick, churning with enough electrical current to generate Earth's entire magnetic field, the same invisible shield that protects the surface from a constant stream of charged particles from space. Temperatures here reach roughly 4,000 to 5,000 degrees Celsius, close to the surface temperature of the Sun itself. Pressure exceeds 1 million atmospheres. No compass would work here. No structure could hold its shape. Just a slow, planet-sized current of molten metal moving in patterns that flip Earth's magnetic poles every few 100,000 years. But even that molten ocean has a floor, and what's underneath it defies what liquid metal should even be capable of. What happens when pressure gets so extreme that a metal hotter than the surface of the Sun refuses to melt? That's layer 8, the inner core, and it begins around 5,150 kilometers down. Despite reaching temperatures close to 5,700 degrees Celsius, roughly as hot as the Sun's surface, the pressure here, more than 3.5 million atmospheres, is so overwhelming that the iron and nickel are forced to remain solid. Some studies suggest this inner core is not one uniform ball at all, but layered itself with an innermost region that may have a different crystal structure entirely, a hidden core within the core. It spins slightly faster than the rest of the planet, a slow, silent rotation that has continued uninterrupted for over 1 billion years. And that leaves us with the final point, the one place on Earth where falling stops meaning anything at all. Layer 9 is not a layer of material. It is the exact center of the Earth, roughly 6,371 kilometers straight down, and it is the strangest destination on this entire list. At this single point, the mass of the planet pulls equally in every direction at once, which means the net gravitational force acting on you would be 0. You would not be crushed toward any single direction. You would simply hang, suspended, at the mathematical middle of an entire planet, surrounded by solid iron, under more pressure than exists almost anywhere else in the solar system, in complete and total darkness, with no light having ever reached this point since the planet first formed 4.5 billion years ago. No wind, no sound, no sense of up or down, just stillness at the exact heart of everything you've ever stood on. If you made it this far into the planet beneath your own feet, you already understand why the ground never felt as solid as it seemed. Drop a like if this changed the way you think about standing outside. Subscribe for more journeys into the extremes hiding in plain sight. And if you're not ready to come back to the surface just yet, the next video on this channel goes even further, past the planet entirely, into the objects in space that make Earth's core look gentle by comparison.